Okay, I'm going to. Okay, we discussed about the error. Sorry. Hello. Yeah. So right. So we discussed about the error. What is error? The difference between actual and predicted. So here, for you to understand very clearly, I have put together a simple table here. Okay, this is what your input feature. This is what your output feature. Right. So you need to predict the housing price. First, you need to train your model with the input as well as the output feature. So what is your model? The model is nothing but this equation, y equal to mx plus c. What is x? X is nothing but your size. In this case, x is your size and price is your y. You need to predict the housing price. Okay. So once you train your model with the input as well as the output feature, I just write it here. This is your input feature. And this is your output feature. Okay, this is your input feature, this is your output feature. So you need to train your linear regression model using this historical data. Let's say this data has been given by your manager or someone. Okay, the customer has given you this data. Okay, so here the 500 square feet based on the past, right? Now the price for the 500 square feet is 1.5 crore, and for 800 square feet 1.2 crore, because the location. Okay, there's some location the cost is less, and here for this square feet this is the price. So this is the data given to you, input as well as the output feature. And you know very well, in the case of supervised machine learning model, like a linear regression model, you need to have both the input as well as the output feature. You need to have both the input as well as the output feature to train your model. Once you train your model with this historical data, which consists of both the input as well as output feature, you will be able to apply this model on the unseen data. Your unseen data is the test data, right? So you apply this model on the unseen data to make a prediction. Okay, fine. So now the question is, okay, now if I plot this visually, right, in a chart, this is your x-axis, this is your y-axis. Here you have the price, housing price. This is what your size in terms of square feet. Okay. So here what will happen is, if you plot it for the 500 square feet house, the cost is somewhere here, right, 1.5 crore. And for the 800 square feet, you will get it is somewhat 1.2 crore, right? And 1000 square feet, so it will come somewhere around here, 3.2 crore. So likewise, we plotted, when you plot this data, it will appear something like this. Correct? Okay. We were discussing about the best fit line. So what do you mean by best fit line here? So how do I? One second. What is the best fit line here? Can I draw a line here? If I draw a line, so see, if I have something like this, for example, if I have something like this, listen, if I plot the data, all the data are, when I plot the data here, instead of like this, if I plot something like this, what will happen? Let's say if you plot the values with your given data set, if your chart looks like this, then you can draw a line, straight line here, right? You can draw a straight line by touching all these data points, because all these data points are available in the same series, right? Here in the same line it is available. If you draw a straight line, it is touching all these data points. But in this case, but this is not happen in all the situation, right? So right, most of the cases you will end up something like this. When you plot the given data, some data point will be there, some data point will be here, and some data point will be there here, and some data point will be there here, and some data point will be there. In this case, how can you draw a straight line? You cannot draw a straight line to touch all the data points. If the data points, when you plot it in a chart, and if that appears like this, then It is pretty straightforward and very simple drawing a straight line by touching all the data points. But in this case, this line should touch the data points, or the line which you draw, that one should be somewhat closer to all the data points. Okay. So now the question is, I can draw any number of lines between this. I can draw a line here and here. Look here, I can draw a line here and here. And I can draw a line here also, right? Somewhat close by this one also. I can draw a line here. Okay, and I can draw a line here. But now you tell me which line is very optimal line. The line which is close to all the data points. You tell me that. For example, if I take this line is close to this one and somewhat, somewhat close to this one, and it is very close to this one. And which one? Yeah, this one. Or let me do one thing. I'll put it like this. So this line is close to this data point, this data point, this data point. But this line is too far for these two data points. Am I correct? I'll just put it in different colors so that you'll be able to make out. So the red color line is close to these three data points somewhat, but it is too far for other data points. And if you take this line, if you draw this line, in this case, for example, this, navy blue color or something like that, right? This line is close to these two data points, but, other data points are too far for this. But if you look at this data point, so this line, if you look at this line is, this line is closer to this one. And one second, I'll just I'll drag this up. This line, the green color line, is somewhat closer to this one, and at the same time, it is somewhat closer to this one. It is not too far for this. It is not too far for this. I will just I will lift it here. Yeah, this line, right? This line is somewhat closer to this and somewhat closer to this. Something like, for all you people, if someone lives close by, so that the equal is for you also, the distance is equal, and for him also the distance is equal to reach out a specific guy, right? Something like this, okay? So this green color line fits this data well, right? But still, if you see here, yes, you need to, tilt a little bit like this. Yes. Now only we can say it is best fit line, green color line. So you don't have to fit the straight line. It is taken care automatically by the model. Okay, by the model. But how the model identifies the best fit line, how the machine learning model, the linear regression model, how it identifies the best fit line, how it identifies the best fit line. So here what happens is, on top of this green color line, you will have the predicted values. The green color line is nothing but your best fit line. The green color line. The green color line is your best fit line because this line is somewhat closer to almost all the data points. It is not, this line green color is not too far for this, and this one is not, too far for these two data set, right? So, and it is closer to this one, and it is somewhat closer. Whereas the red color one or the maroon color one is close to this one, but this red color, if you see, the distance is too far, right? Compared to the green color, the red color line is too far for this data set. Do you all agree with me or not? Sriram left the call. How about Jayashree and Jivanandam? So here, right, the green color line is somewhat closer to all the data points. So red color and the navy blue color, these two lines are too biased, but this line is not biased. It is somewhat. So this point is called your, for example, this is what your predicted value. Predicted value. The predicted value lies on top of your best fit line. Okay, and this is what your best fit line. sorry, the predicted value on, you can see it on top of the best fit line. So now this sits on top of my, so now you understood the, 1 second, I'll just copy and paste it here. Now you understood the green color line is the best fit line. Rest of them I'm going to remove it. So, and if you see here, and it will be somewhat here. So this is the blue colored ones are your actual value. What are they? They are your actual value. I'll just write it here. Actual value. Okay, and this is your actual value. These are your actual value. The blue colors are your actual value. And here this one was actual value. And this one, the maroon color is your predicted value. Okay, this is your predicted value. The maroon color is the predicted value. This is your actual value. Okay. So the blue color is the actual value, which means it represents this one, right? This value. This is your actual value. And the predicted value is this one. Okay, let's assume that in this case, the predicted value is, because the predicted values appear, just below this actual value. Let's say the predicted value is somewhat 1.38C for the first data point. For this data point, right? This data point is which one? This one, 1.5 crore. Okay. And the second one is Sri Ram, don't, I'm monitoring everyone. Don't, leave the call. Okay. So don't depend on others here. Watch the, attend. Each and every person should join and pay attention here. Okay. Okay. Here, the second one is 800, right? 1.2C. But in this case, this maroon color line, the predicted value is just above the actual value, which means the predicted value is more than the actual value. So in this case, what happened? It is somewhat, 1 point, let's say 1.1 crore predicted value. So what about the this one? For example, for this, I just put it here. This is your actual value, and this is what your predicted value. So this is your 3.2 crore. I will just write it at least one data point here, so that 3.2 crore. Three point two crore. Okay, it is appearing in the upside down way. 1 second, I don't know why it is happening. Yeah, 3.2 crore, right? This is your actual value. Which one I'm talking about? This line, 3.2 crore. And what is the predicted value here for this one? That, this, since this value is just above this one, obviously the predicted value should be less than the actual value, but it is way less than your actual value because it is too far from this line. Let's, this one is your 2.9 crore. Or I'll just write it here. This is your 2.9 crore. Okay, this is 2.9 C. Okay, and in this case here you will end up having 2.9 C. Here I just put it here, 2.9 C, and 1,300 square feet is 1.8 crore. In this case, 1.8 somewhat it comes here. Okay, let me do one thing. 1 crore is somewhat here. But even in this case, what happened? The predicted value is just more than this actual value. So maybe it gives me to, let's 2 crore, the predicted value. The predicted value not necessarily lesser than lesser than your actual value. There are cases the predicted value will be more than your actual value, like this. This predicted value is more than this value. That's what I'm trying to say. And next one is the 4 crore, right? So the 4 crore is your actual price, and the predicted value is somewhat here. So this is what your 4 crore, okay? your 4 crore, and this is your predicted value. Let's say the predicted value here in this case is 3.76 crore. Now, what is the error? How will you? This is the predicted value. See, this one will be given by automatically by the algorithm. Don't worry. Okay. How you arrive this? This one given automatically. So now what you need to do is you need to subtract the predicted price from the actual value, predicted value from the actual value. That is what your error. So 1.5 minus 1.38. All of you, please type it in the chat. Can you please help me out? What is the value here? If I subtract 1.38 from 1.5, Sriram, can you type it in the chat window quickly? Calculate. Use your calculator now. Tell me this one. 1.5 minus 1.38. How much, Sriram? 0.12C. Okay, very good. Point. And how about Sriram? And here, 1.2 minus 1.1. 0.1, right? 0.1. And 3.2 minus 2.9, which is your 0.3. And here 1.8 minus 2 crore. In this case, negative 0.2, right? Negative 0.2. And here in this case, okay, in this case, 4 Siemens, right? So here you get something like 2.4, 0.24, 0.24, 0.2. This is what your error. Got it? Very good. Sriram and all your contribution, let it be there. Okay. And next one is I'm going to create another column here. I'm going to add a new column here. Why it is not allowing me to create a new column here? It's a table only. Yeah, insert, right? Insert column to the right. Here what I do is I'm going to square this error. Okay, square this error. So 0.12 into 0.12. So how much you will get? 12 into 12 is how much? 144, right? 144. So in here you'll get 144 and 0.1 is 0.1 only. 0.3 squared, 0.9. And in this case, negative 0.2. I'll just put it here, negative 0.2. Okay, in this case, 0.4. So 2 into 2 is 0.4. And 0.24. 0.24, if you multiply this, how much you'll get? Can someone type it in the chat window? All of you, Sriram, can you help me out? 0.24 into 0.24, how much? So now the question is, why should I square the error? Okay, because we need to add all the errors. Okay, we need to add all the error so that we will get to know for this fitted line, what is the error we are getting it. Guys, remember one thing very clearly. I need, this response. Sriram, yes, 0.576. Is this correct? He says 0.576. Okay, good. Very good, Sriram. Now, if you see here, the negative value got squared here. So why we need to square this error? Because we want to add all the values. When you add all the values, the negative value will get subtracted from the positive value. We don't want that to happen, hence we are squaring it. Hence we are squaring it. And then if you sum all the errors, you will get some value, right? How much you are getting it? Can someone tell me this one? Add all the values and tell me. Sriram, Jayaprashant, Jivanandam. Jivanandam is there? All of you, please, Jivan and who else is there in the call? Soundarya, are you there? Soundarya, she joined. Okay, she left the call. Yes, she. Sai Sudha and Swarna. Okay, can you all please add this and tell me what is the total value here? Make it fast now. Who did this? Jayashree 2.12. Very good. Superb. So here I'm going to put, let me do one thing. I will just go here and insert. .12, right? This is nothing but sum of squared error. .12. Okay. So sorry, 2.02. Sriram says it's 2.02. Is that correct? Which one is correct? Okay. Okay. And for this best fit line, if I use this as a best fit line, this is the error I'm getting it. Same way, if I have, let me do one thing. I will just, if I don't use this line, okay, and if I use this as a best fit line, what will happen? This is very close, and this is very close to this one, but this one is too far from this, and this one is a little far. This is little far. Okay, and if you compare this one with this one, you see here, not this one and this one, right? This value is close by, and this value is close by. This one is close by. This one is close. This is also somewhat close by. But in this case, this one is close to this one, but it is too far for this, right? And for this line, for this maroon color line, okay, the error will be more. It will be more, okay? So for this line, for this maroon color line, if you find, for example, the values are different in that case, okay? So your predicted price will be more, and more, some cases what will happen is the error will be more, which means the predicted and the actual, the difference between the actual price and the predicted price is too much. So in that case, you will end up, for example, for the maroon color line, the sum of squared error is somewhat, let's say you get something like hypothetically, let's say 2.86. This is for your maroon color line. I'll just copy paste this one here. This is what your maroon color, right? If I use this line as a best fit line, the sum of squared is 2.86. And if I use this line, in this case, the sum of squared is, so of these two, maroon color and green color, which colored line has less error? Which color has less error? I need all your response. The reason why I'm asking you to respond here is I want to make sure that you're all concentrating here, you're not sleeping in the call. Or else we will have to enable the videos. Okay, all of us have to enable your video and then have to respond. Okay. Now you tell me which one is smaller, which one is more. This is for the green line. Guys, please wake up, don't sleep. This is not college, okay? They will send you out immediately. If I sleep, they will send me out immediately, right? The companies. I'm not threatening you. Maroon line. And don't blame me. You arranged the interview. You did not explain at all. I explained to everything. You tell me. Maroon line. See, the previous one is the maroon line, right? This one is maroon color line. So all the predicted values are there, but these predicted values are close by these values, but it is too far for this, right? But the green color line is somewhat closer to almost all the values. But for the green color line, the sum of square is 2.12. For the maroon line, it is 2.86. Guys, are you there in the call or not? Sriram and others. And Sai Sudha and Sara. Yes, Sai Sudha responded, Anwar responded, Swarna responded. Only thing is Sriram and Jayashree, can you please tell me? Or Jay Prashant or Jivanandam. Tell me of these two, which one is smaller? Green line error is small, right? So the green line is error small. Very good. This is what I'm asking. Okay. Yes, Sriram. So in that case, the line which gives me lesser error, that is also called as a best fit line. Why we call it a best fit line? Because this line fits all the data well, right? And how do I make sure that, how can I justify that this line is fitting well? Because the error is less compared to the other line, the maroon color line. The lesser the error, better the accuracy. So let's say let's take a simple common sense question. The actual price is 1.5 crore, but when you use your machine learning model and if you make a prediction, if you say for the 500 square feet, as per my model, the predicted housing price is 2.8 crore. Do you think your model is correct? 1.5 is the actual, the predicted is 2.8. What is the difference between these two? That is too high, way too high. That means if you subtract the actual from the, predicted from the actual, you will get the negative value. Because you are, let's say you are up to, let's say 3 crore, yeah. Let's say your model predicts 3 crore. 3 minus, 1.5 minus 1.5 crore. So that means your model is not predicted well. So 0.15 crore squared, if you do how much? 255. The error value is jumping. Okay. So more the error, higher the error, lesser the accuracy, and lesser the error, better the model performance. Look here. Remember that lesser the error, the model accuracy is good. Lesser the error, the model accuracy is good. The opposite is, right? The opposite is higher, more the error, the model accuracy is bad. Okay, it's not good. Okay. Remember this. This is common for almost all the models. Even deep learning, computer vision, you take any kind of AI related models. This is true. This holds good. Okay, for any kind of thing. Okay, fine. We are done. So now you understood what is an error and what is the predicted value, actual price, everything. Right? This is the data set given to you. This is your input feature. The size is input feature. This is your output feature. In this case, we have used only one input feature. See, someone dropped from the call. Who dropped the call? Sriram dropped the call. I don't know why Sriram. Can you ask someone to, ask Sriram to join till the end? Do you think customer will give you the during the status call, they will give the recorded video? No, right? Ask him to join the call, please, quickly. See, others have some issues, a couple of them, they held up in hospital. Some other, they have some issues. Join the call quickly. So this is the one, you get. So this is your error. So why we need to square the error? The interview will ask you, why do we need to square the error? The reason is, you need to add all the error. For each and every data point, there is an error, right? For this data point, this is for 15 crore, 1.5 crore. And the predicted value is 1.38. For this data point, the error is 0.12C. And for this data point, what happened? Negative value you are getting. Because the predicted value is more than your actual value. Predicted value is more than your actual value.